We'll push the button and get going right away. Stretch out a little bit. Alright, we are live on another episode of Dan Does Data. Good evening, everyone. Tonight, we're going back to our roots, back where it all started. TensorFlow. Sorry, I thought I was getting some horrible feedback. Turns out I just have hearing things. Quite alright. So, TensorFlow 1.0 came out just last week. And I'm excited about this, mainly because it's going to stabilize the API quite a bit. I had used TensorFlow for a lot of different things, and then they updated it, and so then I had to change a bunch of my things. And they do have some great tools out there to help you update your code. I have to give them a lot of credit for that. I was doing some of that over the weekend. But it'll be nice that it's a little more stabilized and I don't have to try to remember the new things. One thing that's missing is there used to be this thing called skflow, and I was a big fan of that. It was a simplified interface to TensorFlow. I contributed to it, I really liked it, but it's been moved to TensorFlow, and it says located here. However, it is no longer there in the latest TensorFlow. So skflow is just gone. What it's been replaced by, or what superseded it, I should say, is this thing called TFLearn. And so that's sort of a little more official. TFLearn tries to be a lot like scikit-learn. And skflow is also a lot like scikit-learn. Part of it I think is just a rebranding, and part of it I think is some slightly different things. So I want to show people how to use TFLearn. Pretty simple thing. And we're just going to work through a couple examples. One thing I should also mention, installing TensorFlow is now really easy. You can just use pip and you can install TensorFlow. I think it's just TensorFlow. I already did this. It's going to tell me, oh, it's already satisfied. Fantastic. There's also, actually, let me uninstall it. I'm going to be bold. We're going to uninstall right now. I'm going to see if I can get the GPU version to work. That would be wild if that worked. Let's find out. So, you can, I believe, just say TensorFlow-GPU. And if you're not sure, you can go to the TensorFlow website, click Install, and they have little different instructions. You can build it from source, which I don't really want to do. We're on Linux. If I say TensorFlow with GPU support, because that's going to be much faster. Do they have a list of... you need all this stuff. Oh, you gotta have this stuff. Interesting. They don't say. They say using virtual env. Alright, well, whatever. You know what? Where's the pip version? Pip. That's what I wanted. Yes, I have pip. TensorFlow-GPU. So let's try that. Oh, not uninstall. Install properly. There we go. So this will take 30 seconds supposedly to download TensorFlow and install it. The GPU version, I still am not sure if it's going to work with my outdated hardware. This is why I've often been using Theano for a lot of my lower level machine learning type research. And there's something, their progress bar doesn't really jive with my terminal emulator. That's not a big deal. I mean, this is like the standard TQDM type thing. Ding! And if we import TensorFlow, then as soon as that's done, see if he yells at me. Let's see what happens. Doesn't like that. It claims that it can't get libcuda. Alright, well that's fine. We can uninstall that and go back to the CPU version. I could fight with this libcuda business, but I fought with that a lot before and was not able to get it to work. So we are just going to stick with the CPU version. Which, if you're just on a desktop, it probably just means you're fiddling around. It doesn't really matter. I don't know why it says to download again. It just, unless it's been updated already. But yes, it's now just, you can pip install it, so it's on PyPy. It's great. Let me kill that. Oh, core dump. Well, that's cute. And if I import TensorFlow now, everything should be hunky-dory. It should say yada yada, working with 3 threads, okay, or whatever, how many threads it's doing. So that's how easy it is to install TensorFlow now. There's going to be perhaps some dependencies you got to fiddle with, but pip will handle a lot of the pain. Whereas before you had to download the right version, do this thing, do that thing. It was not obvious. So that's a little bit easier, which I'm a super fan of. All right, but rather than jumping into the like regular TensorFlow ML for beginners or deep MNIST for experts, we're jumping into the tf.contrib.learn quick start, which is this TFLearn, this higher level framework. So I've been using Keras quite a bit, which is also a high level framework. I would say TFLearn, if it's anything like skflow, is even higher level. So it abstracts away a ton of the sort of details that go into your network. All right, I am going to grab this stuff, because that I'm not too worried about. Let's turn on my paste. There we go. Doink. Okay. So let's get NumPy. Yeah, let's do that. Make sure I have my original line there. STF, actually. I like shortcuts. Do some training, some testing. All right, so this is an iris training data set. So it's got a few features of different types of plant irises, and you're trying to classify what kind of leaf are you looking at based on these features. See, what is, my font is not quite wide enough for this. Not found error. Oh, because I didn't have it. Here's the code for the full network classifier. So, where do I get the dang iris code? Datasets, datasets, datasets. Otherwise, iris dataset. There we go. Ugh, come on. It says yes, it's got pictures of irises and it's got these features. And it tells you which species it is, 0, 1, or 2, based on these things. Ah, here we go. Save link as. Yeah, that's fine. Save link as. That's totally fine too. Okay, so I need to do a little bit of rigging around, moving my data. Download / iris star. Move it here. There we go. Fantastic. Let's try that again, shall we? Let's load the training data set. Hey, we have a training data set. Let's load a testing data set. Hey, we have a testing data set. What does training set look like? It's this tf.contrib.learn.datasets.base.load.csv with header. Ugh, that's a lot. If you've used like pandas, it has like similar kind of things, not quite as convoluted. So if you just say training dataset, what does that look like? You get a few different arrays, it looks like. Are they labeled? It doesn't look like they really are. Maybe they are. Training dataset, what options do you have? Count. It's like a list. That's interesting. .target? What's target? Target. So these are the species lists. Which class are we? 0, 1, or 2. There's 3 of them. And if you look at data, that's the actual data. But it doesn't have like actual headers, which is weird. Here's a question. If I look at the iris, show me what this data looks like to begin with. Interesting. So these are the actual, this is what the CSV file looks like. This is the header. The first thing is just 30. The next thing is 4. Oh, I see. The header is, this is how many samples you have. This is how many features you have. And these are your class names. That is a really weird system. Maybe that's standard. I'm not familiar with that system. That's new to me. Oh well, whatever. It is what it is. And the test set, of course, is going to be a similar kind of thing. Data and target. So you'll train with the training set, and then you'll see how good you did on the test set, and your model will have never seen the test set, and so if you do well on that, the idea is, hey, you're doing well. All right, so what did they suggest doing? How do you even go about using this? So first things, they want you, after loading the data, what is this? tf.contrib.layers.realValued column. So you're setting up some empty space for features, it looks like. This is interesting to me. I'm not familiar with this kind of structure. Featured columns. Featured column 0. Right? It's a one long list. Hang on, what is this? What is this thing, kind of thing? Real valued column. Type of it. It's a real value column. So yeah, it's 4 features. That's dimension 4. I don't know what this is about. Tell you what, let's inquire about this constructor. Doink. Creates a real value column for dense numeric data. Pretty typical. Dense as opposed to sparse. If you have sparse data, most of your entries are 0, and there's more efficient ways you could store it and do other calculations, meaning you can deal with much, much larger matrices than you normally would be able to. So we have 4 things. That's why we're going in here. You can specify the type of your thing. So that could be, I guess if it's real value, it's going to be some kind of float, but you could do, tf.float32. Is there tf.float 8? tf.float. There's float 16 is the smallest float. So you do built-in complex? I did not know that. That's cool. Quant size 8-bit? Hang on. tf.q qint 8. I'm not going to apologize for just reading these things. That is what it is. I have to satisfy my curiosity. Oh well. So you have to make some features. Or allocate space, maybe? That kind of thing. What do they say? They say specify all the features have real value data. So I imagine that's just an optimization kind of thing. Maybe you get away without even doing that. And then they build the neural network. Boom, right there. They won't waste any time. Let's work through this. Jeez, oh man. There we go. Ooh. Get these over here a little bit. Okay. So they're going to build a classifier, and the way you do that is tf.contrib.learn.dnn classifier. DNN standing for Deep Neural Network. And yeah, Python's going to help me. That's fine. And you're saying, so you set up the classifier, but you don't pass in the data yet. I see. Feature columns equals feature columns. So what kind of inputs are you getting? This is how many nodes are on each layer. So 10, 20, 10. So you've got 3 hidden layers where you're computing 10 features of the first layer. Those 10 features will be used to create 20 new features in the next layer, and those 20 will be used to create 10 in the final hidden layer. And those 10 will let you compute some score to differentiate your 3 classes right here. And the model dir is just where things are temporarily stored, I believe. So let's try that out, I guess. You know what? Yeah, let's try it out. I imagine you can also change things like the activation and all that are hoot and handy. So tell me about the TensorFlow baloney here. Per process GPU memory fraction 1, keep checkpoint every n hours. Every 10,000 hours, yes, checkpoint, definitely. Interesting, okay. What if I look at classifier? Classifier, what can I do? Predict, bias, config, fit. Where are weights? These have, oh, it hasn't made them yet. So you have to train before you can get some weights. You can't make a random prediction. That's a bummer. That is unfortunate, but params. What is that? So this tells you what activation function you're using. It just gives you a dictionary. So it's function that TensorFlow whatever dot rel rectified linear activation. There is no dropout training. Feature columns, that's the 4 features. Gradient clip norm, not sure what that is. And the hidden layers optimizer, none, because that's going to be chosen during the fitting process. Nope. Okay. Classifier, is there like a set params? I see. So you can set arbitrary parameters, but using a dictionary, I presume. But that doesn't tell me how to actually like create it. What are the options that I can use? Feature columns, sparse feature, sparse feature. Oh, that's cool. Hidden units, estimator, hidden units, optimizer. Oh, so you can set a specific optimizer here. An optimizer is just another kind of object. That's kind of cool. Define input function. This gets detailed. Okay. Let's not worry about that just yet. You can define your own kinds of things. But we have a classifier object. So what you do with the classifier is pull that down a little bit. Say classifier.fit, because this is just like sklearn. Yes, that's what it's called? Yes. sklearn, sklearn. And I have a feeling it's going to be training data. Yeah. So it's X and Y. X is always the features. I think this is not a good use of X and Y, but I'm not going to complain about it. So this is training set.data. Y, of course, is, hang on, training set.target. So you don't have to turn it into one hot format, notice. It's just training set.target. It's just the integer valued things, because that's what sklearn does. So it's trying to be the same. And steps, they say equals 2,000. It's not clear to me, and I know I had this question with skflow either, exactly what that was. It wasn't the number of epochs. Let's find out. Some arguments are deprecated. They'll be removed. They should already be gone. Estimator is decoupled from scikit-learn interface, moving into separate class, yada 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 yada. Max steps. If both steps and max steps are not none. But what does steps do? That's the key that I'm missing here. Alright, well, you know what? Let's do 20. We'll see what it does. That might be some function of the batch size, who knows? Oh, we're getting lots of warnings here. This is interesting. Oh, yeah, because this TensorFlow library wasn't compiled with fancy instructions. That could help speed it up on my computer. Interesting. All these things, logging ops, deprecated, removed months ago. I do appreciate that they put the deprecation warnings in there. That's super cool. Alright. So that should have fitted. So now you should be able to say classifier dot... No, that's not what I wanted. Weights. It's always what I want. I want to look at the weights. Da-da-da! Look at those. So we should have... This should be a list of things. What? It's relatively removed after the deprecation date. Use .get variable names. That's going to get really irritating. I often don't want variable names. I just want to get my things right away. Ah, dang it. There we go. W0. So this is the first hidden layer. Let's import matplotlib.pyplot as plt and plt.ion. There we go. Let me w equals classifier.weights. And then let's plot w0, shall we? That is not what I wanted to do. Nope. w0.shape is 4,10. Right. I don't want plots. I want mate show. Or possibly p color. So here's our four different input features. And if you want to see what they are, it's this sepal length, sepal width, petal length, petal width. So of the leaves versus the flowers, different parts of the flowers, I should say. There we go. Actually, let me not make this color because that's actually kind of confusing here. If I say cm equals plot.cmap.gray r, has no attribute cmap. I always get mixed up which one's which. There we go. So the white ones are very negative. The black ones are very positive here. And so very strong colors give you an important indication that this is an important feature in whatever you're computing. In whatever feature these 10 things are computing, this is what tells you what's important. You could also look at the final layer. That might be interesting. What is W? W's 4 long. Oh yeah, that makes sense. Yeah. You play the same game. Now you've got you've got those 10 features, those 10 final nodes, trying to predict 3 output classes. And see, like, this particular feature is super positive. Hang on, it's irritating. Doink. This feature is very positive. Negative. Very negative for this class. This feature is very positive for this class. And whatever this feature is, feature number 8, that 8 node, is kind of interesting. But we only trained for whatever 20 steps is. Maybe it talks about it in here. Let's scroll down. Fit the DNN classifier. Number of steps to train. Here, 2,000. But what does steps mean? What does it mean? State of the model preserved in classifier. You can train iteratively if you like. Maybe track the model. Really, you likely want to set up a TensorFlow monitor. We might check that out later. No, that's not what I want. Fit, right? Yeah. It does not tell me what steps means. SK, no. Doesn't say. One of those things, man. One of those things. Sometimes you just don't get to know. So I'd love to know exactly what steps means. Is it number of epochs? Is it number of batches? Like, so are we going over 2,000 epochs when we do this? Is that what I'm doing? So it should take 100 times as long. Step. So it blitzes through the steps. And this is our overall loss. Can I get... I wonder if you can specify a metric. So if you get new weights, and then you look at it, well, again, here's your 4 features. This feature, very positive for whatever this weight is. This feature, very negative for whatever this interior. Lots of different things. And likewise, let's see if this is any more illuminating. So, whatever this feature is, why? I don't know why that's freaking out. It's very positive for class 0 and very negative for class 2. So this, whatever this single feature is a pretty good differentiator between those two. The problem we're kind of seeing is there's not a great differentiator in class 1. A lot of these things are gray. But class 0 has a super negative guy here, whereas class 1 is relatively positive there. So 0 and 1 you can sort of pick out, and then 1 is sort of everything else. And that jives with what I've seen of these. If you just like plot what these points are versus all the different classes, you can see, oh yeah, there's a lot of overlap in a lot of these things. Cool, well that's neat. So the powerful thing that we did here was built this. We built this DNN classifier, so we didn't have to like think too hard about this. You could make a much smaller net, like say 5 layers. I'm going to change steps to 200 for reasons. So make a whole new classifier, and is it going to yell at me every time? That could get really irritating if it does that. And let's fit it again. Ding! Okay, cool. And you can get some weights. So now there are only 5 features we're computing from these 4. That's still giving me what? Something went wrong here. Something most definitely went wrong. What? 4, 10? That ain't right. It should be 4, 5. I'm computing 5 things. That's troubling. W1.shape? 10, 3. Why? Is there like a minimum? Did I miss something? Shape and slice spec 5 does not match shape stored in checkpoint. I don't want, screw the checkpoint. Yeah, Jesus. Let's delete, let's del classifier. Oh boy, oh boy, oh boy. I appreciate that it saves the checkpoint. However, when I wish to overwrite the model, I mean it. Is it gonna yell at me again? Invalid argument error. That's weird. It's not matched to shape stored in checkpoint. That's super irritating. So I have to make a new one. I feel like if I'm overwriting it, then I'm overwriting it, and I'm allowed to do that. Alright. Let's see if it's okay now, because I set up a new model directory. Alright, it looks like it did something. Look at that. W. There we go. That looks a little better. There. Now it's 4x5. And so you can see the last feature here, very positive for, negative. Ugh. Get my brain all confused. Very negative for this node 2, this node that we're computing. Whereas feature 1, very positive. So positive, very negative, not a super whole L slot, obviously there. But that was super easy to change the overall size of the network. Just boom, one line tells you how many hidden units you've got. So if you're doing something very simple, or you're just like, you want to fiddle around real quick a bunch, like it does not get easier than that to set up a neural network solution. So that's neat. Okay, cool. You don't want to change n classes here because there are only 3 classes in your model. That's sort of defined by the problem space. If you wanted to combine 2 of your classes, you could do that. That's the thing to do. But we haven't tested our model yet. We want to test. So see how good the model does at predicting the things it hasn't seen yet in the testing data set. And the way you can use that is this classifier.evaluate, apparently. Classifier, I would have thought it was .predict. Evaluate. Some arguments are deprecated. Okay, apparently this is just some kind of scikit-learn compatibility, which is interesting. I would have hoped for more useful information there, because you can use classifier.predict, for example, and yes, some arguments are deprecated. Which ones? Deprecated arguments. Passes some features and it'll predict what the output is. So classifier.predict, and I bet I can say x equals test set dot data. Test set dot data. There we go. That's a generator object. Okay, so if I say what list of that? There we go. So those are our predictions. So if we save those off, just temporarily, and then we also have our test set.target right there. So if I say equals equals, can I do this? So it gets 1 incorrect. That's doing it sort of the long way. But if you're doing evaluate, I guess evaluate will return a bunch of interesting metrics. Let me just do this and see what it says. I want to evaluate things, and then I will grab the accuracy score. Accuracy score, yes, 96. Probably it's getting the same one wrong. So what is EV? Accuracy, awk, area under curve, the global step, and the overall loss. That's kind of cool. So it gives you a bunch of a few interesting metrics, and you can pull out things such as the overall accuracy rate. I'm a little annoyed it doesn't give you the confusion matrix, which every time I say it, I almost say confusion matrix, but that is not what it is. Alright, so in fact, this model is doing fantastic already, and that's on the testing data set, so that's actually pretty interesting. I wonder if I can just leave this hidden units empty. And now I have to go model 3. Actually, maybe tf.contrib.learn.dnn classifier. Maybe there's a way to like overwrite the model. In classes, grading clip. I don't see anything super obvious. Hidden units. All layers are fully connected. Model dir. Can be used to load checkpoints. Oh, so what if maybe if I don't pass in a model dir? What if I just don't? Just don't even bother. Can I do that? Is that a thing I can do? See if he yells at me. Seemed not to yell at me. But what is W? So now we have 0 hidden layers. So this should now just be logistic regression. And now we can actually take a look at our accuracy again. And only 60%. So that's interesting. Logistic regression not quite able to cut it here, which is sort of a very linear method. If you increase a certain feature, that will increase the probability of certain classes and decrease the probability of other classes. And you just keep increasing it and those things keep happening. Whereas here, like, there's probably certain ranges that are important for certain features. And that's what you've been computing with your hidden layer. Okay, that's interesting. What else we got going on in this tutorial? I'm having fun. Classify new samples. Yes, we did predict. We played around with that. Additional resources. Large-scale linear models. That's interesting. Building machine learning estimator in TensorFlow. Experiment with neural network modeling and visualizations. Check out the deep playground. See convolutional neural networks and recurrent neural networks. So I want to see how it handles. Is this straight TensorFlow or is this TFLearn stuff? This is a good explanation of convolutional type stuff, but this needs more code to show you what's going on. Most of this just says, hey, run this code. Here we go. Guide to TF layers, building a convolutional neural network. That is a question I wanted to wonder. So, wait, no, this is TF layers, not TFLearn. Curse is again foiled. I think I'm foiled. No. Let's see. So how to do more fancy layers. And it looks like the answer is the same as it was before. If you want a convolutional neural network, you have to specify that part of it in raw TensorFlow, and then you will add that to your basic model. Where's the basic model here? Calculate loss, return. This is just all class. Features, labels, models. In the end, you return. Model function live.model function ops. Yep. Oh, bother. So this is probably a little more complicated than, say, just using Keras, where everything is like a layer is the first class object, and you just specify your layer in sequence or in a couple different places. Whereas here, it's like you got to specify this. I mean, this is basically the same as specifying a layer in Keras. Do you have to fiddle around with the... Do I have to specify my own weights and stuff, though? Do I have to, like, pass in my own variables? No, but I do have to... That's input layer. That makes sense. Maybe you don't have to screw around with your... making your own variables anymore. Huh. Alright, well, that's interesting. Alright, so... I'm at the point now in the evening where I can decide, do we want to press on and fiddle around with a bunch more TFLearn, or we've gone through the basic thing. Maybe we should just take a look at what some of the options are. tf.contrib.learn. And you can see all these silly things. For example, you can get a deep neural net regression problem, a classifier. What is linear combined classifier? Let's learn. Let's learn TFLearn. Not found. Right. Combined classifier. So what does this mean? Classifier for TensorFlow, linear, and DNN joined to training models. That did not tell me what this actually is. So does that mean like there's a linear features get passed into some neural network and get passed to the end? I mean, that wouldn't be crazy to me. N class is 2, DNN feature columns, DNN activation, linear optimizer, linear feature columns. DNN. Oh, so some things are just passed linearly, and other things get passed non-linearly. All right, you know what? Let's try it. Let's build a combined thing here. I like it. All right, I don't want to keep writing classifier, so I'm just going to call that C. So tf.learn.dnn linear combined classifier. And actually, just so we all are there, let's draw a simple picture of what I think this is going to do. I don't know for sure, but what I think is going to happen. Let me switch to the pencil here. In a normal neural network, you got some inputs. In this case, we have 4. You compute some features based on those inputs. Actually, let me, this stuff. These guys are all weights from your input features. And you're getting over there, and so on and so forth. And then maybe you're computing 3 outputs. And so these various features you computed go towards computing those things. All pretty standard stuff. But what if you've got a couple other features that you think are just related linearly? Well, you could put them into your neural network here, and you could add more nodes, and they could sort of account for that. But if you're pretty sure they're linear, you could just pass them in directly to the bottom, sort of bypassing your neural net. And of course, you're going to need a weight for each feature going to each output. And now we see the awesome power of GIMP right here. So something like that is what I believe this is going to be doing. And to me, that's cool, because that's cool that that's a built-in thing that you can just do. So let's say just 10. Let's keep it simple. Hidden units. This should be DNN hidden units now. DNN hidden units. There we go. And it's no longer feature columns, it's linear feature columns. So we need to set up our feature columns a little bit differently. I'm going to split it into 2 and 2. How about that? So I'm going to say DFC L linear feature columns. I'm going to say we have 2 of them. And I'm going to say that our deep feature columns, we have these 2 of them. So that's going to be the first 2 and the other 2. Pretty simple. So this is not just feature columns now, this is linear feature columns. Linear feature columns equals LFC. And now DNN feature columns equals DFC. And I think this should be fine at this point. Nothing too fancy there. Okay, but now when we go to fit it, we're going to have to pass in our training sets, our different feature vectors separately. The ones we're calling linear and the ones we're calling deep will have to be handled in a separate case. Because now if I say c.fit, it should have options for, son of a gun, it did not. I was hoping I could just do that. I was hoping here it would say, hey, linear features, DNN features, or linear X, DNN X. Maybe I can still get away with it. Maybe it will assume the first 2 are the linears and the second 2 are the nonlinears. We'll see what happens. Let's make this 2000 for giggles. See if this yells at me. Please switch to TF.Scalar. It actually did not yell at me. That's crazy. Alright, well, I was not expecting that to do that well. What's W then? I don't think so. I think something broke here. That's 4, 3. No, something broke. Something definitely broke here. Warning, warning, name error. No, that's fine. Just said warning. It's okay. So I definitely have 10 hidden units. I ran fit. Let's see. Warning. Warning. Instructions for updating, instructions for updating, instructions for updating, yada yada yada. It's doing stuff. It's training. It's getting better, whatever it's doing. Final loss. So why did it not... Like, this is not the correct... Well, maybe it is. No, this isn't right at all. W should be far more things. Oh, that's a classifier. Derp, 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 derp. Really? Object has no object weights. So what does it have? Linear weights, I'm guessing? Yeah, and I should have 2 times 3, I should have 6 of these. I don't. What? That's interesting. So what do my DNN weights look like? Because there I should have 2 times 10, I should have 20 of these. Alright. That shape. That's 4 times 10. That's 4 times 3. Okay. So somehow it's not splitting my things up correctly here. DNN bias, DNN weights, evaluate, export, fit, get params. So how do I train with this then, correctly? Or how do I'm not even setting up the model correctly at this point. Freaking GIMP, go away. Shoot, stupid GIMP stuff. Ah. So that's the question. How do I pass in the 2 separate things to c.fit, basically? How do I let it know? Well, and it's not even... It's really not correct right now. Because maybe it's not doing what I thought it was doing. Maybe I don't have a full understanding of what DNN linear combined classifier means. So let's look it up, you know. TensorFlow DNN linear combined classifier. What does this mean? Really? Oh, well, if I could spell quickly, that would help. So this is the actual code. This is just a link to skflow. What is this? Wide and deep learning tutorial. That is what I thought, yes. Yeah, wide models, deep models, wide and deep models. God, yeah. I hate how this is, how so many researchers put the input at the bottom and the output at the top. It drives me insane. But yes, okay, so it is essentially what I was describing. You've got some features you're doing nonlinear things to. You've got some features you're only doing linear things to. They go directly to the end. See? Same thing. Nonlinear features, linear. Boom. Same thing. So, put them all together in a wide and deep model. DNN linear combined classifier. Alright. Categorical base columns, continuous base columns. Sure, they're making their layers. Oh, they're making each one. The wide model. Linear model with crossed feature columns. No, the deep model, I want combining wide and deep models. Wide columns, deep columns. And then how do you train? So if you don't show me the training line, I'm gonna just might flip. Input function equals training. See, things are so abstracted away. This is another reason I like Keras. It's easy to keep everything in one screen, and I can always understand what's going on. I don't need so many layers of redirection. So train input function equals input function. Input function is this thing. Continuous calls. Categorical calls. See, in Keras, I would just build a functional model, and you could do the same thing. And then it would always be clear what the heck is going on. Maybe not always. Feature calls, return feature calls and label. What? This is strange. Train input function. Train input function calls input function on dftrain. Dftrain is it's reading just a CSV file. So that's their raw data. And then it's splitting that up into continuous and categorical stuff. And the labels, which is interesting. Okay. So that just returns... That does it with an input function. That's not really what I wanted to do. If I have a fit method, I shouldn't have to use an input function, should I? Well, how do I use the input function? Well, it's not described here. Like, I feel like I ought to be able to just pass in an x and a y. Maybe not, though. Feature calls. Dict continuous calls.item plus categorical calls.item. I mean, this is a mess. Putting together this. I definitely did not want to fiddle around with that. That's just a drag. Can I see what's going on in here? Oh, maybe I can a little bit. Deprecated scikit decouple date. Oh. X is deprecated? Y is deprecated? What? That's weird. That's so strange to see that deprecated. Yeah, alright, that's not super helpful. skcompat. If X is not none. Then you do that. So if X is none, and you're doing this input function baloney. Steps is not none. Just self.train model. So it does that using input function, whatever that is. So what does c.train model look like? Of course. Oh, this is a bunch of interior TensorFlow stuff that I don't really want to be looking at. What I want to know is, why did this even run? Right? I mean, if I just pass this in as X, this shouldn't even do anything. In fact, let me give this a new name, just so I don't clobber anything. There we go. Let's do that. Doesn't yell at me, it's totally fine. Happy to do that. It's happy to apparently fit and do something. What it's doing, however, is right. No object weights because it's got DNN weights. But that's dot shape. Yeah, that's 4,10, which is not correct. Because there are only two things here. Two things. Again, this does not tell me how to use this properly. Maybe this does a little bit. Can I not use fit? Input function. I have to use input function baloney. Returns xy, where y represents labels class index. Returns xy. Sparse features, linear features. So I have to define this? That's irritating. I feel like there's a standard thing you would do of, let me specify these features, let me just pass in these features in order. And for a high level thing, that is something I would have hoped I would have gotten. And so what the heck kind of things do I need for input function? df. What the hell is df? Oh, df is your data? Data something something? Data function? Feature name? Fine, we'll call it df. I will call it df even though I do not. It's not clear to me why. I seem to have lost my auto indent there. Irritating. And I want whatever my columns are in each set. He's got names for his columns. When he creates, where do they create the model? Wide columns, deep columns. Okay, so that's this stuff. So let me do that. This isn't crazy. And these are lists. These are just lists. Age, education, known, capital game, whatever. Those are whatever those layers are. Crossed column, hash bucket size. That's interesting. I feel like I'm doing this part correctly. That I've defined my two things, and it's just a matter of extracting out what is the correct thing to return here. It looks like feature calls is a dictionary. But what is going in each dictionary? What is the key and what is the value? And why is there a special key? K for K. What the heck is K? For K in continuous columns. Continuous columns, oh boy, are wacky names. Right? Yeah. Okay. But those don't have actual names, I don't think. Maybe they do. The wide and deep column things. I do not believe those have proper names. Oh, they do. They do have proper names. All right, fine. Fine. We will remake this. So yeah, the tutorials, like they run through the simplest possible example, and they say, oh yeah, it's so easy, no problem at all. Let's just go x1, 2, 3, 4, 2, 3, 4. 4. There we go. So the left-hand side will then be a little more simple. Be x1, come x2. I'm arbitrarily declaring those two to be the linear guys. Then we should be able to do this. Okay, then we need a linear function with our df for data frame, I bet, is what it is. And this shouldn't be all that complicated. What the heck are they doing here? Oh boy. They're doing something wacky. Indices, values, shape, what? We're just in continuous. So this is setting up a key of the name and all the values for that guy. So I'm going to look at training set.data. So what am I saying here? Linear equals df not df.data x1, and it's df of the first column, which is all the rows, comma first column. And you know what, we can just do this, x2, and that's df of all the rows, comma next column. There we go. And rather than linear, or deep neural network side of things, 2, 2, 3, 3. And we perhaps can return, these are the joined? Yeah, okay. Predictive. Linear dot, ooh, let's see if I can spell that. Items plus DNN dot items. And linear is a function, not, or dict is a function, not itself a. Alright, but I need the label as well. Okay, so I have missed one key component. Need to say data on all these things. Data, because we're just going to be passing in the data frame in total. And labels are going to equal, is this even tf.constant? I have to set up this stuff myself. Converts labeled column to a constant tensor. What a mess. So you can see how this quickly gets more complicated. And like in Keras, I would know what I'm doing instantly. df.target. Let me see. Targets. All right. Yes, that should be fine. Yeah. Comma labels. And now it's going to be d.fit of model input function. Hang on. Input function equals input function. Except they have its input function of this thing. Of dftrain. Oh, I see. So I just need a dummy function here, is all. Because I can't pass in my actual data apparently. And dftrain is already defined up here, is the actual data file, yes. So you have to find a little function to make your data. Training set, and this will be testing set. Testing set. And then this is going to be train input fn. And is that called? No. Not like that. Okay. Steps equals 2000. Sure. Let's run all this stuff. I'll just grab all this, all of it, everything. We're grabbing everything. We're grabbing everything. On all this too. This is now getting more complicated for library, a call that should really not be all that horrible. Dict items and dict items. I can't do that? I can't just add items together? I thought I could. I thought they'd do that here. Could have sworn they did that here. Maybe they don't. They definitely do that here. That's okay. I don't really care. Because what we're going to do, we're just going to call this features. And we're going to come over here. There we go. Make one big guy. Boom. That was easy. Now it's dictionary. And now I just pass in features. Boom. Done. Easy fix. Has no attribute get shape. Got burned. I gotta pass in the shape too, apparently. That's also gotta go in my... Why does that have to go in my... is it really expecting these all to be panda data frames? Why? I just wanted NumPy. That's all I wanted. Curse you. It's a little irritating. Let's turn on the Python debugger. See what it says here. What does it say? Tensor. What is Tensor? Tensor is my NumPy array, in fact. That is some form of my data. So it is getting in there. It just, it's all kinds of mucked up. And like, I could convert it all to stupid stupid stuff, but I don't really want to do that. Can I just grab the shapes and pass that in? That's what they seem to do here. Shapes. That seems to be just another... Oh no, that's part of the sparse tensor. Never mind. Why the heck? That's a little weird. Alright, so we are coming up. It is now after 7 o'clock. We did some basics with TFLearn. We tried to do some more complicated things. Those things did not work, turns out. This other TFLearn tools seem to require more of a pandas approach than a NumPy approach. And it's not as obvious to be able to use them. It looks pretty easy to specify, like, oh, this is all you need, but if I have to... Oh, son of a gun. This is still like 4. 1 second. I will try this whole thing again. No, okay, never mind. So it looks at first like it's going to be very simple. You know, it's one line call to build this neural network of a special shape and size. But if I got to set up all my variables, now I've got to think about that again. If I have to specify a special input function, that's getting kind of irritating, and I'm having to spend a lot of time essentially fighting with the API just to get that to work. And I'd much rather be fighting, you know, trying to figure out what is the best kind of neural net to my problem, or solving more applied projects using machine learning tools. So for me, Keras is still offering a better approach than this TFLearn. I might spend a little more time with it. I might poke around with the Keras in TensorFlow. But so far, Keras is still, for me, a little bit nicer than this. I very rarely fight with the API of Keras. It lets me focus on the fun part of the machine learning. All right, that is all we got for tonight. We've used up all of our allotted time, so thank everyone for coming out. And don't forget, stay safe in the data mines. Take care.